Welcome back to Excel Rapid Focus series. I'm Khaleel. Today we are discussing the chapter Polynomials from grade 10 Maths. Let's do our first question. Find the zeros of the quadratic polynomial 6x square minus 3 minus 7x and verify the relationship between the zeros and the coefficients of the polynomial. So here 6x square minus 3 minus 7x, which is our polynomial, we have to factorize that and we have to find the zeros first. So let's start. 6x square minus 7x minus 3. First of all, I rearrange the third and second term, 6x square minus 7x minus 3, to the standard form. Then we have to split the middle term. Minus 7x is the middle term, right? So we have to find two numbers. Their product is minus 18. 6 into minus 3, right? Then their sum is minus 7. So which are the numbers? Negative 18 is the product and the sum negative 7. Yes, minus 9 and 2, right? Negative 9 and 2. So we can split 6x square minus 7x as minus 9x plus 2x minus 3. So what is common here? Here 3x is common. So we can take 3x. So what is remaining? 2x minus 3 remaining, plus here 2x minus 3, we can write it like that. Then we can put a bracket also here. Then what is common here? In these two, what is common? 2x minus 3 again common. So 2x minus 3 again common. We can write the remaining 3x plus here 1 remains, so 1. So 2x minus 3 and 3x plus 1 are the factors. So from here we can find the zeros alpha and beta. So 2x minus 3, it will be equal to 0. So 2x minus 3 will be equal to 0. So 2x is equal to 3, x is equal to 3 by 2, alpha is equal to 3 by 2. And 3x plus 1 is equal to 0, 3x is equal to minus 1, x is equal to minus 1 by 3. So beta is equal to minus 1 by 3. Now we have to verify the relation, right? So from here we can find the ABC. A equals 6, B equals minus 7 and C equals negative 3. These are the values of ABC. So let's start the verification. We have to verify alpha plus beta is equal to minus B by A, right? So we can substitute the values. Alpha 3 by 2 plus beta negative 1 by 3 is equal to minus B by A. Minus of B is equal to already negative 7 divided by A 6. So let's cross multiply here. It becomes 9 minus 2 by 6 is equal to negative become positive, 7 by 6. So 9 minus 2, 7 by 6 is equal to 7 by 6. Hence verified. The first one finished. Then the next one, we have to verify alpha into beta is equal to C by A. So alpha into beta means 3 by 2 into negative 1 by 3, right? Yeah, negative 1 by 3 equal to C by A. C is equal to minus 3 and A is equal to 6. So here we can easily cancel these 3's. So negative 1 by 2 is equal to, which become negative 1 by 2. Yes. So which is also verified. Hence verified. The first question is over. Very easy question. So let's move to our next question. This is our next question. Find the quadratic polynomial, the sum of whose zeros is minus 5 and the product is 6. So in this question we have to find a quadratic polynomial. In the previous question the quadratic polynomial is given. We have to find the zeros and we have to verify. Here we have to find a quadratic polynomial, right? Yeah. So x square minus sx plus p, which is the general form. Okay. To form a quadratic polynomial, x square minus sx plus p is the general form. So what is meant by s? S is the sum of zeros, means alpha plus beta, and p means product. So alpha into beta is the product. So here minus 5 and 6, which are the sum and product, which is given. So alpha plus beta is given, which is minus 5, and alpha into beta, the product of the zeros, is given, which is 6. We just want to substitute these values into the general form. The general form, x square minus sx plus p. So alpha plus beta is the sum, which is minus 5, so negative x plus, and alpha into beta 6. So here for product p we can put 6, so it become x square plus 5x plus 6 is the required quadratic polynomial, right? It's an easy question. We can easily form a quadratic polynomial if the sum and product of the zeros are given. We can use this general form x square minus sx plus p. S for sum of the zeros, alpha plus beta. P for product, alpha into beta. So let's move to the next question. This is our third question. Find a quadratic polynomial whose zeros are 5 plus root 2 and 5 minus root 2. So the zeros are given here. 5 plus root 2 and 5 minus root 2 are the zeros, not the sum and product. So we have to find the sum and product. Then you can do the same. We can do the same thing. So we can write alpha is equal to 5 plus root 2 and beta is equal to 5 minus root 2. So here we have to use this formula x square minus sx plus p. So first of all we can find the sum alpha plus beta. What is the sum of these two? 5 plus root 2 plus 5 minus root 2. So root 2, 5 plus root 2 plus 5 minus root 2. Root 2 cancelled out, 10. Then product alpha into beta. Alpha into beta is equal to 5 plus root 2 into 5 minus root 2. So here we can use the identity a plus b into a minus b, right? So it become a square. So 5 square minus b square, root 2 square. So 25 minus root 2 square become 2. So 23 is the answer. So the sum is equal to 10 and product is equal to 23. So we can easily form the equation, quadratic equation. How? X square minus sum is equal to 10x plus, then product p is equal to 23. So which is the final required answer. Easy. So let's move to the next question. Find a quadratic polynomial whose zeros are given by minus 4 by 3 and 1 by 2. The same question. So we have to find the quadratic polynomial. So x square minus sx plus p. So the zeros are given here. So alpha is equal to minus 4 by 3 and beta is equal to 1 by 2. The zeros are given here. So we have to find the sum and product. So what is the sum? Sum is equal to alpha plus beta, which is equal to minus 4 by 3 plus 1 by 2. So which is equal to minus 8 plus 3 by 2, which is by 6, which is equal to minus 5 by 6. Yes. Then p, product is equal to alpha into beta, which is equal to minus 4 by 3 into 1 by 2, which is equal to minus 4 by 6, which is minus 2 by 3. Yes. Now we can easily form a quadratic equation, right? So x square, the sum is equal to minus 5 by 6, negative 5 by 6, x plus product is negative 2 by 3. Okay, so x square minus sx plus p, there is a negative sign in the general form. So x square plus 5 by 6 plus x minus 2 by 3. But here we have to remove these fractions because which is not in the standard form. So we can multiply the whole equation by 6. So it becomes 6x square plus 6 into 5 by 6 x minus 6 into 2 by 3. So these 6 cancelled out, these cancelled out 2. So 6x square plus 5x minus 4 is the required quadratic polynomial, right? Easy, right? Here 6 and 3 we can easily cancel with 6. That's why we multiply with 6. So let's move to the next question. This is our next question. Find a quadratic polynomial. Again we have to find a quadratic polynomial whose 1 0 is 5. So we can mark it as alpha. Alpha is equal to 5. And the product of the zeros means alpha into beta. Alpha into beta is equal to 30 is given. So what is beta? 5 into 6 become 30, right? So beta is equal to 6. So alpha and beta are here. So we can find the sum. Sum is equal to 5 plus 6, so 11, and the product is equal to 5 into 6, 30. So easy. X square minus sx plus p. So x square minus 11x plus 30 is the required polynomial. So let's move to the next question. This is our sixth question. If alpha beta are the zeros of the polynomial p of x is equal to 4x square plus 3x plus 7, then find the value of 1 by alpha plus 1 by beta. Alpha and beta are the zeros of this quadratic polynomial. We have to find the value of 1 by alpha plus 1 by beta. So anyway, first of all we can list the relation, which means here a is equal to 4, b is equal to 3, c equal to 7, right? And alpha plus beta is equal to minus b by a, which is the relation, first relation. So minus b by a we can write it as minus 3 by 4, and alpha into beta become c by a. So c by a 7 by 4, which is minus b by a and which is c by a. Okay. Then what we have to find? We have to find 1 by alpha plus 1 by beta, right? 1 by alpha plus 1 by beta. We can cross multiply this one. Then it become alpha plus beta by alpha beta, right? So here we don't want to do anything. We can directly substitute the alpha plus beta and alpha into beta here. It's already, the value is already here. So the value of alpha plus beta is equal to minus 3 by 4 and alpha into beta is equal to 7 by 4. Okay. So division by division, we have to multiply with the reciprocal. 4 cancelled out. Minus 3 by 7 is the final answer for this question. Let's move to the next question. 7th question. If one of the zeros of the quadratic polynomial k minus 1 x square plus kx plus 1 is negative 3, then find the value of k. So we have to find the value of k here. One of the zero is given. So minus 3 is a zero of polynomial, which means p of minus 3 will be equal to 0. If minus 3 is a zero of polynomial, we can say p of minus 3 will be equal to 0. So we can substitute minus 3 for x, right? Yeah. So k minus 1 into x. So minus 3 square plus k into minus 3 plus 1 will be equal to 0. So k minus 1 into 9 plus minus 3k plus 1 will be equal to 0. 9k, we can open this one. 9k minus 9 minus 3k plus 1 equal to 0. 9k minus 3k become 6k minus 9 plus 9 minus 9 plus 1, minus 9 plus 1 minus 8. So minus 8 become plus 8. So k is equal to 8 by 6, k is equal to 4 by 3 is the final answer. So which is the 7th one. Let's move to the next question. 8th question. If the zeros of the quadratic polynomial x square plus a plus 1x plus b are 2 and minus 3, then find a and b. Here in this question, the zeros alpha and beta both are given, 2 and minus 3. So alpha is equal to 2 and beta equal to minus 3. Both are given. So we can use the relation between the zeros and coefficients. That's very easy. So alpha plus beta is equal to minus b by a, right? So here alpha we can choose it as 2 and beta minus 3 is equal to minus b by a. Here a equals 1, b equals a plus 1, c equals b. So minus b by a become minus of a plus 1 divided by 1. So it become minus 1, which is equal to, when we open this bracket with negative, it become minus a minus 1. So we can put this a to the left hand side. So it become positive and this negative 1 to the right hand side, minus 1 plus 1. So a equal to 0. Then we have to find the value of b. How we find the value of b? We can use the second relation. Alpha into beta equal to c by a. So 2 into minus 3 is equal to b by 1. So which become minus 6 is equal to b. So a equal to 0, b equal to minus 6. Option D is the correct answer. Let's move to the next question. 9th question. If 1 0 of the quadratic polynomial 2x square plus px plus 4 is 2, one of the 0 is given, so we can mark alpha is equal to 2. Find the other 0. So we have to find beta. Also find the value of p. Okay, so first of all we can list A equal to B equals P, C equals 4. So we have to find beta. So we can use the second relation. All of you please listen here. We can use the second relation, alpha into beta is equal to C by A, because here we can use these two. Then we can easily find beta. So 2 into beta is equal to C 4 by 2. Yes, then beta is equal to 4 divided by this 2 become at the denominator, so 2 into 2 4, so beta equals 1. So we can find the second zero easily. Beta equals 1. Yes, then we have to find the value of P also, right? So how we find the value of P? Alpha plus beta equals minus B by A. So alpha plus beta, alpha is equal to 2, beta is equal to 1, which is equal to minus, B is equal to P by A equals 2. Yes, so negative P is equal to 2 plus 1 become 3, and this division divided by 2 become into 3, so 3 into 2, so negative P is equal to 6, so P is equal to negative 6. So second polynomial beta is equal to 1 and the value of P is equal to minus 6. Very easy, right? So let's move to the next question. The 10th question. If the sum of the zeros of the polynomial P of x is equal to k square minus 14 x square minus 2x minus 12 is 1, then find the value of k. So what is 1? If the sum of the zeros means alpha plus beta, which is given as 1, so we can mark it as 1. Then we have to find the value of k, right? So we can use this relation. What is alpha plus beta? Alpha plus beta equals minus B by A. So we can replace alpha plus beta by 1 and then we can substitute minus B by A. So that first of all we can write A equals k square minus 14, B equals negative 2, C equals negative 12. So we can substitute. Alpha plus beta is 1, which is given. 1 is equal to minus B by A. So negative 2 by A is equal to k square minus 14. So we can shift this denominator to here. So it becomes k square minus 14 is equal to plus 2. So k square is equal to 2 plus 14, k square is equal to 16, k is equal to plus or minus root 16 become 4, right? So k is equal to plus or minus 4. Very easy question, right? If you have any doubt, please pause the video and watch again. Next, let's move to the next question. 11th question. Form the quadratic polynomial whose zeros are 7 plus 2 root 2 and 7 minus 2 root 2. We did the similar question earlier, right? So anyway, the alpha is 7 plus 2 root 2. The zeros are given and beta is equal to 7 minus 2 root 2. So we can find the sum for this equation. X square minus sx plus p is the general form. So what is the sum? Sum here 2 root 2 and minus 2 root 2 cancelled out. Only 14 remains. And product we can use a plus b into a minus b, right? Yeah, a plus b into a minus b. So 7 plus 2 root 2 into 7 minus 2 root 2. So which is equal to 7 square minus 2 root 2 the whole square. So 49 minus 2 root 2 the whole square. So 2 square become 4, root 2 square become 2. So 4 2s are 8. So 41 remains. We have to form a quadratic equation, right? So this is the general form. So x square minus, what is the sum? 14x plus product 41, right? Yes. Okay, so next question. If alpha and beta are the zeros of the quadratic polynomial such that alpha plus beta is equal to 24 and alpha minus beta is equal to 8. So alpha plus beta is equal to, which is given, alpha minus beta is also given. Find the quadratic polynomial having alpha and beta as its zeros. So we have to form a quadratic polynomial with alpha and beta are the zeros, right? So here we can list the given conditions. Alpha plus beta is equal to 24 and alpha minus beta is equal to 8. Easy question. We can eliminate these two, then find alpha and beta, then we can find sum and product, then we can do the same thing, we can form a quadratic equation, right? Yeah, do it. So alpha plus alpha, 2 alpha is equal to beta and minus beta become 0. 24 plus 8, 24 plus 8, 32. So alpha is equal to 32 by 2, alpha equals 16. Then what about beta? Alpha plus beta is equal to 24, right? We got alpha as 16. So beta is equal to 24 minus 16. So 8 remains. Yeah, beta is equal to 8. So we got alpha and beta. Next, we have to form a quadratic polynomial. So x square minus sx plus p. Find the sum and product. Sum is equal to 16 and 8. 16 plus 8 become already given, which is 24. Yes. Then alpha into beta. 16 into 8, right? 16 into 8, which become 15 into 8 become 120. So 120, 128. Yeah, 128 is the answer. So x square minus 24x plus 128 is the required quadratic polynomial. Okay, easy question, right? Let's move to the next question, the 13th question. If the sum of the zeros of the polynomial x square minus k plus 3x plus 5k minus 3 is equal to 1/4 of the product of the zeros, the sum of the zeros is equal to 1/4, right? Yeah, we have to find the value of k. So anyway, we can write the relation first. If the sum of the zeros means alpha plus beta of this one is equal to 1/4 of the product, means alpha into beta, okay, which is the relation. Next, we can substitute alpha plus beta as minus b by a, right? Alpha plus beta is equal to minus b by a. What is minus b by a here? And alpha into beta is equal to c by a. We can substitute the values here. Minus b by a become negative of negative k plus 3, which is b, by a. What is a? 1, right? Yeah, 1, which is equal to c by a. 1/4 of c by a. Alpha into beta is equal to c by a. Okay, we can replace c by a here. So c 5k minus 3 divided by 1. Okay, so here these two negative sign become positive. So k plus 3, this divided by 4 we can take to the left hand side. So it become 4. Division become multiplication. So 5k minus 3 remains here. So we can open the bracket. 4k plus 12 is equal to 5k minus 3. Then we can shift this 4 to the right hand side. So 5k minus 4k, 12 plus 3. So 5k minus 4k, 1k, k is equal to 12 plus 3, 15. K is equal to 15 is the solution. Very easy question, right? Here the sum of the zeros alpha plus beta is 1/4 of the product. 1/4 of the product means 1/4 into alpha into beta. Okay, just replace with minus b by a and c by a. Very easy question. Okay, so let's move to the next question. Yeah, 14th one. If one zero of the polynomial 3x square minus 8x plus 2k plus 1 is 7 times the other, find the value of k. So here 1 0 is 7 times the other, right? So before that, first we can list the a, b, c. A equal to 3, b equal to minus 8, c is equal to 2k plus 1 is the c here. Okay, yes. Then 1 0 is 7 times the other. So alpha and beta are our zeros. We can choose alpha and beta as 7 alpha because it is 7 times, right? Yeah. Then we can use the first relation. Alpha plus beta is equal to minus b by a. Alpha plus beta is equal to minus b by a. Then alpha plus beta, we can write it as 7 alpha is equal to minus b by a, negative 8 by 3. So alpha plus 7 alpha become 8 alpha, which is equal to 8 by 3, right? Yeah, 8 by 3. So what is alpha? We can cancel this 8, right? Alpha is equal to 8 by 3 into 8. These 8s are cancelled. So alpha is equal to 1 by 3. Then what about beta? Beta is equal to 7 alpha, 7 times the alpha, right? So we can choose it as 7 by 3, 7 times. So 7 into 1 by 3, which is equal to 7 by 3. Okay, so alpha and beta are here. So what we have to find? We have to find the value of k. So we can use the second relation. Now here we use the first relation, alpha plus beta is equal to minus b by a. To find the value of k, we can use the second relation. So the second relation, alpha into beta equal to c by a. So what is alpha? 1 by 3 and beta 7 by 3, which is equal to c by a. What is c by a? C is equal to 2k plus 1 by a is equal to 3. Yes, so from here it becomes 7 by 9 is equal to 2k plus 1 by 3. Then we can put this 3 to here, then it becomes 3 into 7 by 9 is equal to 2k plus 1. So 3 and 9 cancelled out. Here 3 times, then 2k plus 1 is equal to, what is remaining? 7 by 3, right? Yeah, 7 by 3. 2k is equal to 7 by 3 minus 1. So 2k is equal to 7 minus 3 by 3. So 2k is equal to 4 by 3. So k is equal to 4 by 3 into 2. This 2 become here. So 2 4s are cancelled out. So here 2 times. So k is equal to 2 by 3 is the final answer. Okay, k is equal to 2 by 3 is the final answer. Yes, 15th question. Obtain the zeros of the quadratic polynomial root 3x square minus 8x plus 4 root 3 and verify the relation between its zeros and coefficients. Related to the first question, the same as the first question, right? Yes. Anyway, we can write the quadratic equation root 3x square minus 8x plus 4 root 3. So we have to factorize using middle term splitting. Then we have to find alpha and beta. Then we have to verify. So let's start. So here minus 8x we have to split. So we have to find two numbers, their product and sum. Product is root 3 into root 3, 3 into 4, 12, and their sum negative 8. So which are the numbers? Their product is 12 and sum is equal to minus 8. Yeah, negative 6 and negative 2. Negative 6 and negative 2. Yes. Negative 6 into negative 2 become positive 12. Yes. So we can write root 3x square minus 6x minus 2x plus 4 root 3. Okay. So what is common here? What is common here? We can write root 3x square minus 3 into 2 is 6, right? So that 3 we can write root 3 into root 3 into 2x. Okay, root 3 into root 3, 3 into 2, 6. Yes. Then minus 2x plus here 4 you can write 2 into 2 and root 3. Okay. Then what is common here? What is common here? Here root 3x is common. So x minus 2 root 3 remains. Yes. Then what is common here? Here negative 2 is common. So x minus 2 root 3 again remains. So in these two, again x minus 2 root 3 common. We can take the remaining root 3 x minus 2. Yes, which is remaining. So the next step, we have to find alpha and beta. X minus 2 root 3 is equal to 0. X is equal to 2 root 3. So alpha is equal to 2 root 3. And beta, what is beta? Root 3x is equal to, root 3x minus 2 is equal to 0. So root 3x is equal to 2. X is equal to 2 by root 3. So which is beta? Beta is equal to 2 by root 3. So now we get the alpha and beta, right? Yes. So we have to verify the relationship. We have to verify alpha plus beta is equal to minus b by a. So what is a here? A is equal to root 3, b is equal to negative 8, c is equal to 4 root 3. These are the ABCs. So we can verify this first. Alpha plus beta. Alpha 2 root 3. plus beta. What is beta? 2 by root 3 is equal to minus b by a. We can substitute the values. Minus b by a become minus 8 by a is equal to root 3. Yes. So we can cross multiply here. Then it become 2 into root 3 into root 3. 3 into 2, 6 plus 2 by root 3 is equal to negative become positive 8 by root 3. So 8 by root 3 is equal to 8 by root 3, hence verified. First one over. Next one, alpha into beta is equal to c by a. Alpha into beta means alpha into beta 2 root 3 into 2 by root 3 is equal to c by a. What is c by a? What is c? Yeah, here 4 root 3 by a. A is equal to root 3. Okay, so these root 3 cancelled out. These root 3 cancelled out. 2 into 2, 4 is equal to 4, which is also verified. So the relationship's verified, right? Yes. So our 15th question over. Let's move to the next question. Next question. If alpha and beta are the zeros of the polynomial x square minus 4x plus 7, find the values of alpha square plus beta square. We have to find alpha square plus beta square. Anyway, all of you please listen. What is alpha plus beta the whole square? Which is equal to alpha square plus beta square plus 2 alpha beta, right? Which is in the form of a plus b the whole square. Yes. Here we have to find alpha square plus beta square. So alpha square plus beta square will be equal to alpha plus beta the whole square minus 2 alpha beta. I just put this one to the left hand side. Okay. So which is the required identity in this question. Anyway, we can list the alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Okay. So what is alpha plus beta? Alpha plus beta minus b by a. So minus 4 by 1, which is equal to alpha plus beta is equal to 4. And alpha into beta is equal to c by a. So 7 by 1. So alpha into beta is equal to 7. So alpha plus beta and alpha into beta are here. Then we can use this identity to find the required answer. So we have to find alpha square plus beta square, which is equal to alpha plus beta the whole square minus 2 alpha beta, right? Here, what is alpha plus beta? Which is equal to 4. Yes, so 4 square minus 2 times. What is alpha into beta? Alpha into beta here. Alpha into beta 7. So into 7. So 4 square 16 minus 14, which is equal to 2. So 2 is the final answer. So let's move to the next question. Here 2 is the answer. Yes. 17th question. Here again the similar question. If alpha and beta are the zeros of the polynomial x square plus 4x plus 3, right? Yeah, there is a change in the c. Okay, we have to find the value of 1 by alpha plus 1 by beta and 1 by alpha square plus 1 by beta square. We have to solve two questions here. So what is 1 by, first of all we can list alpha plus beta and alpha into beta. Alpha plus beta is equal to minus b by a. So which is equal to minus 4 by 1 minus 4. Then alpha into beta c by a, which is equal to 3 by 1 3. Okay. Then first one, 1 by alpha plus 1 by beta we have to find. So what is the next step? We have to cross multiply this. Okay, when we cross multiply this, it become alpha plus beta by alpha into beta. So we can directly substitute the values. It's already here. So alpha plus beta minus 4 by 3. So which is the answer for first one? Very easy, right? Then next, second one, we have to find 1 by alpha square plus 1 by beta square. Yeah. So here we can cross multiply. Okay. So it become alpha square plus beta square. We just cross multiply. Then alpha square into beta square. So which become alpha plus beta, alpha square plus beta square by alpha beta the whole square. Yes. In the previous question, we can use alpha square plus beta square as we did, which is alpha plus beta the whole square minus 2 alpha, right? Yes. So we can use the relation here, the identity here. alpha plus beta the whole square minus 2 alpha beta, which is equal to alpha square plus beta square, and denominator alpha into beta the whole square. So we can substitute the values. What is alpha plus beta? Minus 4. So negative 4 the whole square minus 2 alpha beta. So 2 into 3. Yes, 3. Alpha into beta is 3 divided by alpha into beta the whole square. So alpha into beta 3 square become 9. So the answer become minus 4 square 16 minus 2 into 3 6 divided by 9. So which is equal to 10 by 9 is the required answer. Okay, first one we got minus 4 by 3 and second one 10 by 9 is the final answer. Very easy question, right? Yes. Then 3 more questions remaining. Yeah, let's check the 18th question. If alpha and beta are the zeros of x square plus 7x plus 7, find the value of alpha inverse plus beta inverse minus 2 alpha beta. So it's a similar question. What we have to find? Alpha inverse plus beta inverse minus 2 alpha beta, right? Yeah, what is alpha inverse? Which is equal to 1 by alpha plus 1 by beta, beta inverse 1 by beta minus 2 alpha beta. When we cross multiply this one, we can directly substitute our relationship. Which relationship? The alpha plus beta we know, which is equal to minus b by a. What is minus b by a? 7 by 1 minus 7, right? Yeah. Then alpha into beta, which is equal to c by a. Again 7 by 1 7. So these are the sum and product, right? Yeah. So we can use this here. When we cross multiply here, we have to find this. Okay. So when we cross multiply, it become alpha plus beta by alpha into beta minus 2 alpha beta. Just substitute the values. Minus 7 by 7 minus 2 into alpha beta 7, right? Yeah, alpha beta is 7. Alpha into beta is 7. Yes. So minus 7 by 1 become minus 1. 2 into 7 become minus 14. So the final answer negative 15 is the final answer. Okay, very easy, right? Please copy the answer. Let's move to the next question. 19th one. Yes. If alpha and beta are zeros of x square plus 5x plus 5, find the values of alpha inverse plus beta inverse. Also, form a quadratic polynomial with zeros is alpha inverse and beta inverse. Yeah, okay. Anyway, let's solve. Before that, we can list alpha plus beta is equal to minus b by a. So minus 5. And alpha into beta is equal to c by a. So which is 5. Okay. Anyway, first of all, we can list this one. After that, we can check what we have to find. First of all, we have to find alpha inverse plus beta inverse. Alpha inverse plus beta inverse is equal to 1 by alpha plus 1 by beta. Just cross multiply this one. So it become alpha plus beta, alpha into 1 alpha, beta into 1 beta by alpha beta. Okay. Just cross multiply. Then we can substitute. What is alpha plus beta? Negative 5. What is alpha into beta? 5. So negative 1 is the answer for the first question. Also, form a quadratic polynomial with zeros is alpha inverse and beta inverse. So we have to form a quadratic polynomial with zeros, alpha inverse and beta inverse. So 1 by alpha and 1 by beta, which are equal to alpha inverse and beta inverse, right? So we have to form a new quadratic polynomial. Its zeros are 1 by alpha and 1 by beta, which means alpha inverse and beta inverse. So when we have to form a quadratic formula, we have to use x square minus sx plus p. We have to find the sum. So the new sum s is equal to 1 by alpha plus 1 by beta, right? Which is the new sum. S means alpha inverse plus beta inverse actually. Yes. So 1 by alpha plus 1 by beta we have to find. So we can cross multiply, then it become alpha plus beta by alpha beta, the same equation we did here. So which is equal to minus 1, right? So we can directly write the answer minus 1. Then for the product, now we are forming a new quadratic polynomial. Its zeros are 1 by alpha and 1 by beta. So we have to find the sum and product again, right? Yeah. So this is the sum and product. 1 by alpha into 1 by beta, which is the new product. So 1 by alpha beta, which is equal to 1 by, what is alpha into beta? Alpha into beta is equal to 5. So 1 by 5, which is the new product. So we can form the quadratic equation. X square minus sum is equal to minus 1x plus product 1 by 5. So it become x square plus x plus 1 by 5. But here we have to multiply with 5 to remove the fraction. So we have to multiply with 5. So it become 5x square plus 5x plus 5 into 1 by 5 cancelled out. 5x square plus 5x plus 1 is the final answer. Easy, right? Yes, we have one more question. Yes. If m and n are the zeros of the polynomial 3x square plus 11x minus 4, find the value of m by n plus n by m. Similar question, the zeros alpha and beta are changed to m and n, which is the only difference. So we can write the relation first for this polynomial. M and n are the zeros, right? So we have to change m plus n, alpha plus beta. Instead of alpha plus beta, we have to write m plus n. It's equal to minus b by a. So minus 11 by 3. Then m into n. M and n are the zeros here. So m into n, c by a, negative 4 by 3. Okay? Yes. Then what we have to find here? We have to find m by n plus n by m. So which is equal to, we can cross multiply and find this form to substitute. So we can cross multiply. So m square plus n square by mn, right? When we cross multiply the required value, it become m square plus n square by mn. In the numerator, we can use the previous identity, which is that m plus n the whole, m square plus n square the whole square become m plus n the whole square minus 2mn, right? Divided by mn, which is the identity a square plus b square is equal to a plus b the whole square minus 2ab, the same identity. Okay, so which become m plus n negative 11 by 3 the whole square minus 2 into mn, m into n minus 4 by 3 whole divided by mn again. So minus 4 by 3 again. So which will be equal to 121 by 9 minus, this become plus 8 by 3 whole divided by minus 4 by 3 become minus 3 by 4, multiplication with the reciprocal. So here we can cross multiply, then it become we can use LCM method here. We can multiply 3 here and here, then it become 121 plus 24, 121 plus 24 divided by 9 into negative 3 by 4. So here 121 plus 24 become 145 divided by 9 and 3 we can cancel. Here 3 times and a negative sign remains. So negative here and 3 4s are 12. So minus 145 divided by 12 is the final answer.